Welcome everybody. So what I would like to do is I would like to show you or explain to you who is hosting this conference first of all, and then give you an idea what IPA is doing in robotics, and then get into the history also a little bit of open source development, and then hand you over to the real talks about Roscon. So Fraunhofer is called Fraunhofer because there was a man, he was a researcher on the one side, he found the so-called Fraunhofer lines here, which now enable us to, for example, detect the type of material that you're looking at. He also was an inventor. He invented, for example, machining processes to do better lenses. And also he was an entrepreneur. He became pretty rich after all of these inventions. So we thought, or the people in Fraunhofer thought, that that's a good role model for us. Fraunhofer is one of the largest institutions for applied research in Europe at least, with more than 60 institutes, more than 22,000 employees, and more than 2 billion euros in budget. The billions are American billions, not the German billions. Fraunhofer IPA is one of the large manufacturing institutes, or the largest institute in the area of manufacturing. We had a budget of over 50 million euros in 2012. Out of that were almost 20 million coming from industry, and we're having almost 400 scientists and almost another 400 student scientific assistants. We're working in the area of automation, robotics, medical technology, vision system, non-destructive testing and all of that. But also I have a colleague who's focusing on the area of business organization, quality management, sustainable production, and all sorts of coatings, even electroplating. So we have a pretty wide range with regards to manufacturing. Whatever is possible to do automation with, we do it. And in the area of robotics, we have around 100 people working in that area, and we're doing anything all the way from conceptual design down to specifications, all the way to system implementation, mostly in industrial or industry-related projects. We're not developing a lot of new robots, but we're developing a lot of new applications with robots or for robots. And we do a lot of special robots, like the Carabot, which is also our most liked or most interesting toy, I would say, also with regards to ROS. But we also had, for example, robots, hosting robots for museums, which are running for 10 years and several thousand kilometers already. We did, for example, offshore service robots, hydrogen fueling robots, climbing robots to do window cleaning, and lots of robots in the industrial area also, all the way from bin picking to packaging to special applications in the assembly area. So, what do we do with open source? I would like to first of all look at the history of open source and how we view at it, how we look at it, and then to give you some ideas what we're exactly doing on the area of open source development. So in the 60s, if you look at the history, money was earned by really selling hardware rather than software, and software was only a minor portion of the R&D cost. And the source code came along with the machine. You didn't have to pay for it at that time. In the 70s, the first version of Unix came around at AT&T, and there was free access to universities, but no support, no bug fixes at all. And the support started later on through the University of Berkeley and the Usenet of Unix. In the 70s and 80s, I think Bill Gates can take credit for making separate parts or separate business cases on the software and the hardware business, him focusing on the software business. Software became more and more complex, and there was some refinancing necessary. So all these software companies grew and managed to get paid also. In '84, Richard Stallman started the GNU project and the Free Software Foundation, which was another important milestone, we think. And also in the 90s, Linus Torvalds started the Linux development and merged it with the GNU project. So there were some roots all the ways up down to the 80s. We think another great step towards open source applications was really the introduction of Netscape in 1998. Open source software became more important, got larger impact, and there was more and more applications to follow in that area, and all of them spread faster and faster. I think a lot of you use some of these applications still, like VLC and so on. And today, I think open source is everywhere, in consumer goods, in automation. For us, as the automation guys, obviously automation is the most interesting. Even in Germany, we have a club called OSADL, which is another club making NC controls and all the interfaces that you need for NC controls open source and distributing it through my university institute with some industry partners also. So even the very old economy, the mechanical engineering, the machine tool companies found that open source is really a good idea to go in the development of that area, for example. There is lots of different applications around. There is lots of license models, lots of different business models around, and which one you choose or whatever has an impact on us, we'll see in the future. Open source in robotics beyond ROS is the names that you can see here on this slide. Libraries for planning, for perception, for kinematics, and so on. There's so many other things going on. And at some point in time, people always need to find the right distinction between what is going to be open source and what is still proprietary, closed source. But I think there's a lot of nice business models on the way already. So with this, looking back in history, I would like to show you our motto, which is, it is always better to stumble on new paths than getting stuck on old roads. And I think you do something very similar to that. You try new ways of developing stuff. You even meet on weekends, which is also different from the regular. And you meet very early in the morning. I hope you have a wonderful conference, a lot of good exchange in information, new ideas. All the best to you. Thank you.